All right, welcome to section 10.1, the language of hypothesis testing. We just got out of chapter 9, where we were doing our inferential statistics and we were estimating a parameter, either the population proportion or the population mean. And now our inferential statistics, we're going to be doing hypothesis testing or testing claims. And we're going to be testing claims again about the population mean or the population proportion. So let's return to a previous example in section 9.1. Remember we had this problem where we had a survey and it was found that 542 have used their smartphones to make a purchase, and I made a comment that that's probably outdated, that it's probably much higher these days. And so we saw that the p-hat for this example was 0.15 for this sample, and we're thinking that it's probably much larger. So it's probably a larger proportion that have used their smartphones to make a purchase. Okay, so using a confidence interval, it was estimated that our population proportion was between 0.1 and 0.6. This seems low, so let's examine the situation. Okay, so using our p-hat 0.15, we can make a sampling distribution of the sample proportion. And we can just say 0.15 for now. So this is what our finding was. But we think that it's not true. So let's say we go in here and we look at a different sample and we get a new p-hat, and because we think this is wrong because it's probably larger, our new sample is going to reflect that. So let's say this is where our new sample is, right there, p-hat. Okay, so what's going to happen, because it's so much larger, the area to the right is going to be small. And so we know that that means this is unusual. All right, given the population has that proportion of 0.15. Okay, so in reality what's happening is that this is not small and unusual. The problem is the mean of the sampling proportion is wrong. The sampling distribution of the sample proportion is wrong. So what's actually happening, and let's use a different color, maybe blue, maybe what's actually happening is our mean is closer to our new sample proportion. So maybe this is what actually is going on. And then if we look at this probability of happening with what is really going on in the population, now this is not unusual. This is kind of meat and potatoes, right? All right, so again, this blue one is the actual distribution of p-hat. Okay, so this is essentially what we're going to be doing in our hypothesis testing. We're not going to be making all of these pictures, but it's that philosophy. And let's kind of write it out in the language we are going to be using. So when we have a hypothesis test, we have an old theory and a new theory. The old theory is like the status quo, so what is already accepted. And then we have our new theory. So what we call the status quo, we call it the null hypothesis. And it's that old idea. So we can think of this as, again, the status quo or the old idea. And in our case, our null hypothesis was that the proportion of the population that have used their smartphones to make a purchase is 0.15. And so we would write P is equal to 0.15. And it's the population proportion. That's why we're using P and not P hat. And then our new idea was this stuff in blue, and what we're going to be testing, or we did test with that P hat. So the alternative or alternate hypothesis, our new idea, the one we test, this is the one we're testing. So we test this one. And in our case, we don't actually say what the proportion is. We just think proportion is more than 0.15. And so in words, or excuse me, symbols, we write population proportion more than 0.15. Okay, and then we test it. So a couple of hints. Your null hypothesis always has an equal sign. So null hypothesis always uses an equal sign. The alternative hypothesis is something other than equal sign. So in our case, it was greater than. We can also test less than. We can also test just not equal to. Okay, so let's put into words what this process was when we took our p hat, our new sample proportion, to test this claim. All right, so remember what happened when we were on our old curve. We took a new sample and looked at the new proportion, and it was considered unusual, right? And it wasn't by chance, it's because the actual distribution was shifted, right? It's this original 0.15 was too low. Let's write that out. Okay, so what we did, and it's important that we understand this because this whole process is going to be expedited very much in the upcoming sections. Suppose we took a sample and p hat is much greater than 0.15, so much so that it's considered an unusual event. So to the point that it's considered unusual. All right, so an unusual event, again, how we're going to determine it's unusual, normally it's just less than 5%. But now we're going to do two new ways. And I'm going to write it out. We're going to see it in more detail in section 10.2. But it's going to be considered unusual if the probability of occurring is small. Probability of occurring is small. Or we can say the same thing as we are far away from the mean. So we're enough standard deviations away from the mean. So we have two different ways now of determining if something's unusual. All right, and there's three ways, and we've talked about this a lot. Three reasons why something is an unusual event. So 3 reasons why we get an unusual event. I'm going to write event up here. One is luck of the draw. Or a bad sample. We haven't really talked about that, but a bad sample is definitely a reason. So by chance, a bad sample that doesn't reflect the population. But the one that we're going to assume for our inferential statistics in this case was that the population is actually more than 0.15. So population proportion, that is, P, is more than 0.15. And that's what we're going with. So then we can conclude, let's see if I have enough room to write this, our conclusion is that we would say we have evidence to suggest the population proportion the population proportion is more than 0.15. All right, so notice we say, we don't say that the population proportion isn't 0.15. We don't even say that it really is more than 0.15. All we say, and again, it's because we know there is some error just based on the nature of samples, all we say is we have evidence to suggest this. All right, and so draw your own conclusions, really. Okay, so let's talk about the hypothesis of testing the parameters. We just do mu and p, mean and proportion, in this class. We skip discussions on standard deviations. So first of all, the hypothesis testing is only for these parameters from a population. We never do a hypothesis test on sample statistics. You're never going to see hypothesis testing on X bar or p hat. So that's the first point, or the first thing I want to say. So first is we make a statement about the population parameters. And again, we just use mu or p. In our hypothesis statement, and I'll write this in red because I'll take points off, we never make hypothesis statements about X bar or p hat, because that information is already given to us. We can find X bar and p hat all day long, but the inferential statistics is about mu and p, it's about the population. Okay, so again, we have our null hypothesis. We state that first. Our textbook uses this symbol, H sub 0. We say H naught. And then we have our alternative hypothesis. And then our textbook uses H1. And the symbols that we see again, null always has an equal sign. And the alternative can be greater than, less than, or not equal to. So in our example that we just did, we would say our null hypothesis is that the population proportion equals 0.15. Our alternative, the parameter stays the same, the number stays the same, always. And now we use one of these three symbols. And in this case, we say that the proportion is probably bigger than 0.15. So that's your first step to do your hypothesis testing. And then you collect your evidence. and we collect evidence to try to support our alternative. Because that's what researchers do. They say, hey, I think it's this. I'm going to go out and collect evidence to see if I can support that. Okay, and then after we analyze the data, to see if it's unusual or not. So we're going to assess the plausibility of H1. Of the alternative. H1 is the alternative. All right, so in this case, we determined that our sample statistic, p hat, was unusual. So that's really what we mean when we're assessing the plausibility. Is our statistic, our sample, unusual or not? Okay, and so really, when we're analyzing it, we're asking ourselves the question, does it support or not support H1? And that's going to eventually be our conclusion. It supports the alternative or it does not support the alternative. All right, so we're going to get into the nitty-gritty details in section 10.2. For now, you guys are going to continue section 10.1 on your own. It's a lot of reading. You guys are going to answer questions. And then I am going to post the key after you guys have read everything, and you guys can check your answers.